Our next presentation, it is going to be a presentation on asset management approach in Eskom transmission with a focus on asset health management. And the presentation is going to be delivered by Teboho Ramorapeli. And before Teboho can start, I also have his bio here, which I'll just read out. So Teboho Ramorapeli is a maintenance strategist manager in Asset Strategy Department under Asset Management in Transmission, responsible for leading and directing transmission asset lifecycle management plans. He has over 20 years experience in working in the electrical engineering industry in various roles, with some of these outputs, such as power quality and network performance management, electrical maintenance planning and execution, safe operating of extra high voltage networks, network and plant risk management, refurbishment and strengthening projects, execution and commissioning, safety, health, environment and quality management, and technology management. He holds a BTech in electrical engineering from CUT, a Master of Science in Electrical Engineering from the Wits University, and is registered with EXA as a professional engineering technologist. He has co-authored chapters in the Eskom book titled Power Quality in Electrical Power Systems and presented a paper at Sigray Regional Conference. Over to you, Teboho. And if I may just remind everyone again that your questions are actually welcome, and you can type them in the Q&A and we'll address them during the panel discussion. Thanks, Teboho.
Thank you, Chair. Good morning to you, panelists, as well as the attendees. If I may share my screen, I will be sharing the asset management approach in Eskom transmission with focus on asset health management. The presentation will be divided into two parts, where the first part will be sharing the journey of transmission in terms of asset management, and as well as demonstrating how asset health assessments assist in terms of making sure that we manage the risks, as well as where the end of life has been reached, we can then be able to do refurbishment and the complexities around this part of the process. As we all know, transmission is a very big business looking after assets, and we transport the electricity from power stations and make sure that they reach distribution as well as municipalities. To fulfill and maintain all these mandates, we need to make sure that there's increased focus on our assets, and the value that is created is very essential. So we'll share the journey as well as demonstrating how this has assisted the business in making sound technical and financial decisions for a sustained revenue flow. Transmission as a business has an asset base of 126 billion, consisting of AG plant assets based at substations, with the high value being transformers and reactors. And then we also have secondary plant assets that then first protect this high voltage plant. We also have metering systems that ensures that the billing is done correctly. And we have DC as well that ensure that in case of failures at the substations with no power, you have batteries that can then be able to supply the protection so that your assets are protected. We also have then lines spanning about 32,698 kilometers that then transports all this power at extra high voltage from power stations to various load centers. We also have telecom towers that assist with the communication. So we are a high intensity asset management business. In terms of the journey over the years, transmission pursued asset management initiative from 2009, where as well in 2013, NESA asked Eskom to demonstrate progress on asset management practices, so that when we apply for tariff increases, we can then be able to show that we are looking after our asset and we are making sound financial decisions. We as well participated at ESCO as secret work group to develop ISO 55001 between 2016 and 2019. And ESCOM in 2021 established the Asset Management BU under the leadership of Prince Moyo, who's also the chairperson for SAIEE, and Victor Shikwan, who's managing the Asset Strategy Department. In terms of our journey, we have put a policy that aligns with the corporate plan as well as the transmission visit plan to make sure that our plan centers around the expansion plans for growth, operational plans for flexibility, maintenance plans for life cycle management, as well as refurbishment plans for end-of-life management. So we are developing plans in terms of asset management plans and making sure that all the documents that talk to maintenance are fully done correctly. We are as well currently embarking on tools, digital tools that will assist the system to be able to be fully functional, to support the APMs, the AIP in terms of how we decide on the life cycle, as well as how we prioritize the project and around the project execution. We are actually at the point where we will be sending out the RFIs to the market so that they can share what they have and then be able to integrate the systems. And on the process and plan side, these are the timelines that we've put through for ourselves, where you can see in terms of the governance processes, we've completed a couple of activities, and on the processes and on the asset management approaches as well, we have set those target dates so that by end of 2025-26, we are then able to have a fully fleshed asset management plans that will then be able to take us to be able to be certified in that regard. Now, Chair, moving to the asset health indices, we have different assets as I explained in previous slides. And here you can see this is the dashboard that we use to show assets that are in very good, fair, poor, and very poor conditions. And on these assets, we are using different analysis to decide on each asset, which will be discussed in the next slide based on different criteria. First, on this criteria, we're looking at protection systems. As you can see, we still have phase 1 and phase 3 relays that have been living above its life of 20 to 30 years, averaging around 35. And most of the ones that we found them to be in not so good conditions are on the feeders, HV and MV, where now these lines are expected to treat for faults and make sure that they isolate the faults. For the health assessments of protection systems, we don't necessarily look at the age alone, but the risk to the network. So in other words, you'll want to have, especially at power stations, to have protection that is working adequately at key customers. We're looking at the failure rates of these protection schemes and the skills that we have in the business, as well as the space that the OEM can support in terms of technology. So if the technology becomes obsolete, then you are unable to then continue with the protection schemes that you have. So we are putting projects to make sure that we extend the life of some of these assets, and then we as well issue protection projects for that. Just to demonstrate some of the work that has been done, as you can see on the top picture, you have replaced ABB DPU that was frequently failing on the MV feeders, where mostly are radial lines, replaced with the ABB REF feeder. We also use portable line protection schemes, where we call them washing machines, where we implement projects on critical lines, or where the protection may have failed on a feeder. We can use this protection scheme as a temporary measure to keep the line in service. In the future, if you look on the right, we have at news transmission station, as we implement these projects, where IEC 68150 has been implemented, we also include engineering stations so that when settings are implemented, or if you want to do the relay downloads, you don't necessarily have to connect through your laptop, but you can have all these engineering stations able to assist you in that regard. We are also integrating solar panels at various stations, but in these instances, we still use normal protection, but we ensure that we put line VTs so that we can be able to detect all the faults from all the sources of supply in that regard. Looking at the other assets, it's looking here at the protection assets, at the plant assets, which now focuses on transformers. You can see that our life of this protection, primary plant assets, transformers, it's quite long. We had estimated around 40, but with good designs, operating them well and maintaining them well, we are seeing as well transformers living in excess of 56 years. And we know that as we do oil samples on a periodic basis, what is quite important that will determine the useful life of a transformer is the DP, which is the paper. Once the paper is faded or is degraded, you know that the transformer will have to be replaced. However, in between, we also look at your dielectric strength and as well as the DGA, which can show you if there's developing faults. And on the table here, it shows some of the limits that we use to determine if we have some of the arcing that is happening or local overheating. And we also use the wall triangles for further analysis in combination of this DGA that we're picking up from our transformers. So the strategies for management of these assets, transformers, is to do maintenance, make sure that we test them, do some intrusive work, and in some instances, run to failure with a strong strategic space as a supporting measure. A typical example of some of where the life was prevented from a failure, you can see here, we had a transformer that had a DGA that was increasing, and one of the engineers that we're working together with, I think it's in the session run, we detected this and applied the concept that I've shared in the previous slide. We then had to do electrical tests on this transformer, and you could see that using two different methods, because before you can do internal inspection, which costs a lot of money, you need to be sure that there's definitely a developing fault inside this transformer. So using two methods, you could pick up that there's a problem or on the selector switch, and then this asset that is worth way over 40 million, we could then be able to inspect it, pick up the fault, order a new selector switch, and then being able to replace it and put the transformer back into service at a cost of around 4 million, saving the business more money, as well as ensuring that we don't experience environmental incidents. Because as transformer fail, you have oils that gets taken out, and in most cases, they can safely go out to your oil dams. In terms of our overhead lines, here the key components are two. The first part of doing asset health management is through the first part, which is steel structures, where we're looking at the foundations, the tower footing resistance, the steel structure itself, and we look as well as the conductor itself, which is part of the overhead conductor system, asset class, conductors, the spacers, and things like the OPCW that assist with communication and the headlights. And if you look at the age profile of our lines, most of our lines are way above their 50 years and are performing well, with only about 8 lines that are shown to be in the red. And most of those are the lines where towers, in some instances, are inside the water, where we've got earthing issues, where we've got earth wires that are frequently breaking, and in some instances where hardware is important, or where we have heavy last in some instances. So here we manage the risk through maintenance interventions, testing, and some instances, selective replacements of certain parts, etc. Now with the lines, we use different methods. Here you can see the placement of insulators that have aged or where they've been frequently breaking using of helicopters. Here where we find that the assets have rusted, we initiate project then to do selective refurbishment on those parts. But supported in terms of technology, we're using helicopters with gimbals attached to it that will then assist you in being able to detect corona discharges, hot connections that will otherwise not be able to see with your naked eye. We are also now introducing drones that have multi-spectral cameras to assist you to do IR scanning and also be able to see when you're doing detailed inspections on your asset. In terms of projects where we've seen now these assets have reached the end of life, can be seen here that over the past few years, we've had a shortfall of about 1.774 billion due to shortages of funding. And we've had to then now cut some of the projects by reprioritizing and just doing most of the critical work that is to be done. And in some instances, we've had some under expenditure as well. And I'll share some of the challenges in the next slides. But mostly we've tried to do what we can with the budget that has been allocated. And the recent study that we've done as well showed that to be able to clear all the assets that have demonstrated to be in the red and in the orange, we'll need a budget of about 9.5 billion in the next 5 years. So every year we'll need about plus minus 1.4 to 1.8. And as you can see, currently we have only been given around 608 million to do refurbishment. Looking at the history of what we've been replacing in the past 10 years, you can see we've replaced a couple of assets, and we are as well planning to replace other assets as the finances and the budget gets allocated to the business. And here is just a typical transmission project where we were implementing the refurbishment project. There's complexities around when the panels have to be, new panels have to be connected, because in the HVR sometimes you find that the cable trenches are full of conductors, and in some instances where we are supplying radial customers on HV lines, you have to build bypasses so that you can then be able to temporarily put these customers on supply. We have to use trucks in the HVRs while doing stringing. And here you can see we have to upgrade FMETs, and sometimes people can damage those cables. So we need to make sure that everybody who's working inside the HVR, it's working safely. And in this specific project, we've managed to spend 114 million, and the project was executed safely within time and within budget over a period of 3 years, even with those challenges. And in conclusion, Chair, Eskom Transmission has embarked on this asset management journey over the years, and we are working on formalizing it in line with ISO 55001, with the hope that we'll then be able to be certified. And in this presentation, we've demonstrated that asset classes have been helpful in identifying risks and assisting the utility to manage them through various interventions that if municipalities can implement as well, they'll then be able to get a better money from their assets and then have their good revenue flow. And I've also tried to share that if we are to eliminate the risk in terms of assets that are not performing well, or that the condition is not in the good condition, we'll need high budget supported by strong project management to execute this project. I would like to end there, Chair. Thank you very much.
Thanks, Teboho, for that presentation, giving us the Eskom transmission perspective. So certainly the issue of health, it is not something that is left for humans or animals. Even physical assets have lives, and if we understand their health, we can definitely manage them better. Thanks for that, Teboho.